Hi there, welcome to my YouTube channel. I'm Nahid, and in this video, I'm gonna talk to you about one of the most popular and useful tools in the world of software development. Yes, as you know from the title of this video, it's Git. But before we jump into this interesting topic, let's ask two questions. How Git revolutionized your workflow and make collaboration seamless? And also ever wondered how Git empowers teams to track changes, coordinate work, and maintain version control effortlessly? So, in order to answer these questions and gain knowledge about Git, let's have a deep dive into it. Before diving into Git, let's have an overview of version control system so that we know where we stand and what tool we are going to learn about. For this purpose, we can ask ourselves what is version control and what is the need for it. As an official definition of version control, I should say version control, also known as source control, is the practice of tracking and managing changes to software code. Version control systems are software tools that help software teams manage changes to source code over time. As development environments have accelerated, version control systems help software teams work faster and smarter. On the other hand, I should mention that version control software keeps track of every modification to the code in a special kind of database. If a mistake is made, developers can turn back the clock and compare earlier versions of the code to help fix the mistake while minimizing disruption to all team members. Good version control system supports a developer's preferred workflow without imposing one particular way of working. Ideally, it also works on any platform rather than dictate what operating system or tool chain developers must use. Great version control systems facilitate a smooth and continuous flow of changes to the code rather than the frustrating mechanism of file locking. Now that we have checked more details about version control systems, it's time to start to know more about Git and talk about its benefits and usages in the world of software development. Git is a version control system that developers use all over the world. It helps you track different versions of your code and collaborate with other developers. If you are working on a project over time, you may want to keep track of which changes were made, by whom, and when those changes were made. This becomes increasingly important if you end up having a bug in your code. Git can help you with this. But Git can also be a bit scary and confusing when you first start learning it. So, in this video, I will introduce Git in a humanly understandable way. I will talk about some topics such as repositories, commits, branches, and much more. So, let's get started. As the first important question here, I should ask, what is Git? As I mentioned before, Git is a version control system that you download onto your computer. It's essential that you use Git if you want to collaborate with other developers on a coding project or work on your own project. In order to check if you already have Git installed on your computer, you can easily open your terminal and type the command git-version. If you have already Git installed, then you will see what version you have. But otherwise, if you don't have Git installed on your machine, you can open easily your browser and type git install, and after that click on this link, getting started. As you can see here, there are different constructions for different operating systems: Linux, Mac OS, and also Windows. Based on your operating system, you can choose one of them and follow the construction. For example, for Linux, you can use the first one for Ubuntu and the second one for Debian-based distribution. But if you are using another distribution, you can click on this link, and inside this page you can find your distribution and follow the related construction. After completing the whole process to install Git on your machine, you can come back to your terminal, type again git -- version and check the current version. The second important question is how to get started with Git. You can either use Git by typing commands in the terminal, or you can use a graphical user interface or GUI such as SourceTree or Gitkraken. If you choose the terminal, you will have to look up which Git commands you will need. Luckily, you don't have to learn these by heart. Other than a handful of commands that you will use most often, the rest you can look up whenever you need them. This is what most developers do, even those with decades of experience. Git offers in-depth documentation on their website. If you choose to use a GUI, then the various actions you need to take will be displayed in a more visual manner. Whatever you choose to use, the terminal or a GUI, you will need to understand the basics of how Git works in order to use it confidently. For the rest of this video, I will share examples using Git in the terminal, but the steps I share are very similar if you are using a GUI. Okay, the next question is how to prepare my project folder in Git. To use Git, we need to have a project that we want to version control. This can either be a new project or an existing project. If it is a new project, then we need to create a new project folder and then navigate into that project folder in the terminal. If we were to choose an existing project, then we simply navigate into that project folder in the terminal. In my example, I will create a new project folder called Git Basics, and after that I will create new project. So open PHP Storm, and on the top left corner click on File and New Project, and in here you can choose your desired location. For example, for me is Git Basics folder in desktop. So for creating new project, I will name it Git Example, click on Create, and that's it. We have a new project named Git Example. So if I open the folder named Git Basics, I will see the new project. It's empty for now, but that's enough to open this folder and this project in the terminal. So click on Open in Terminal, and yes, we have it inside the terminal. And as you can see here, we are in the directory desktop and Git Basics, and that's okay. So as the first concept in Git, I want to introduce repository to get more familiar with it. The next question that I want to ask now is, what is a Git repository? The repository is the .git folder inside our project folder. It will track all the changes made to the files in our project and record that history over time. The repository that we have on our computer is referred to as the local repository. When we push, in other words, upload our local repository to one of hosting services such as GitHub, Gitlab, or Bitbucket, the repository that resides in these services in the cloud is referred to as the remote repository. It's important to use a remote repository in order to be able to collaborate with other people, as well as to back up our projects in case something happens to our laptop or computer. Okay, now that we have an overview of the definition of repository in Git, let's try it in practice. Once we are in our project folder, In order to start using Git, we will need to create or initialize a repository using the git init command. So, open again your terminal, and as you can remember, we are in our project folder, but we should go inside our project. So, let's navigate to Git example project. So once we execute the command git init by typing it in the terminal and pressing enter, it will probably seem like not much happened, but don't worry. Git can be sneaky sometimes and it carries out a lot of actions behind the scenes. In order to see what Git did behind the scenes, we should go to our project folder and check the existence of the new folder named .git. So open your project folder, and what we should see now is a .git folder inside our project folder. This is generally what represents our repository. So for some specific situation, if you can't see the .git folder, don't worry. Click on 3 lines menu on top right corner and check Show Hidden Files. So now that we have a repository on our local machine, it's time to create a repository on a Git server. In this step, let's choose a Git server and start it. For this purpose, I will use Gitlab. So let's do it. For now that we have a local repository, it's time to create a remote repository because we should connect these two repositories. For this purpose, open your browser, type Gitlab sign up, and you can choose sign up or sign in. I assume that you have a Gitlab account, so in sign in page, you can use the upper form and it needs only to put your username and password inside it. Or as a second option, you can use another account like Gmail. So select your desired account and that's it. I'm now in my Gitlab account, and as you can see here, there are several cards that I'm gonna explain them a little bit more. There are create a project, create a group, and other ones. As the first card, let's open explore public projects. So click on this card, and as you can see here, you have access to the whole public projects that other developers have shared here. You can check each of them that you like and find more details about them. Another card is learn more about Gitlab. In this card, you can find so many useful links about different topics like official documentation, Git commands, how to organize projects, and so on. But for now, let's open the card for create a project, and I will talk about the card for create a group later. So click on create a project card, and as you can see here, there are several cards again, and they are for the way of creating new project. For example, you can create a new blank project or create it from a template, and etc. For now, I will choose create blank project. So in this form, we should enter some useful information to have a basic project like project name, and also you can check project slug. Also, there is another field for project deployment target that is optional, and you can select it or leave it. Next one is visibility level that has 2 different levels. Private for all projects that you don't want to release them publicly, and also public level for some situation that you like to share your project with other developers. Also, as the last field, we have project configuration, and you can choose your desired configuration. For example, if you like to initialize your repository with your README file or not. And at the end, just press Create Project button, and that's it. As you can see here, you have now a new project named Git Basics, but let's explain something here that are so important. The first one is Git Global Setup. In here, you will find some configurations that you should add them to your local project, and I will use them soon. The next parts also related to 3 different ways that you can connect your local repository to this new remote repository. The first one is for situation that you don't have local repository and you want to create and connect it to this remote repository. The second one is for situation that you have a local repository and you only want to connect it to this remote repository. And the third one is for disconnecting a local repository from another remote repository and connecting it to this remote repository. As I mentioned before, let's create a new group before connecting this new remote repository to our local repository. So for this purpose, click on this icon and then click on Groups menu. And as you can see here, there is a page for managing groups. In Gitlab, you can use groups to manage one or more related projects at the same time. And also you can use groups to communicate with all group members and manage permissions for your projects. If someone has access to the group, they get access to all the projects in the group. You can also view all the issues for the projects and also analytics about the group's activity. So for creating new group, just click on New Group button and Create Group. In this page, you will find a form for creating new group. So let's select a name for this new group, like Git projects, for example. And also you will find the dedicated URL for this new group. And after that, you will find visibility level. As before, it's private and public. Also, there is role for this group, for example, software developer, and another item for who will be using this group, my company or team, or just me. So let's click on just me. And at the end, you will find what will you use this group for. For example, I want to store my code. And at the end, just click on Create Group button. And that's it. We have a new group named Git Projects. And also you can create new project inside this group by using this card, or you can also add all your projects to this new group. Now it's time to connect our remote repository to the local repository. For this purpose, I want to do it from local side. This happens with the help of the git remote command when the repository is first created on local, and then the user connects it to the remote repository. A git remote command is used to make the remote connections, such as connecting a Git local repository with GitLab remote repository. Now it might look like that Git remote is a live exchange of data between a local and a remote repository. This is not the case. Git remote is just a connection between the local and GitLab repositories. Through Git remote, we provide a name to the repository through which we can refer to the GitLab repository. In other words, Git remote can be considered as a reference to the GitLab repositories, which do not provide any real-time access to what you do locally. Also, Git remote command can be used to connect to your own repository or to connect to someone else's repository. Now, let's see how to link an existing local repository to a remote GitLab repository. Let's coming back to the same GitLab page and checking the section named Push an Existing Folder. In here, we can find the whole required commands step by step. Before starting, let's check the upper commands for Git global configuration. By doing this, you will introduce your credentials and you can have access to your GitLab account from local repository. So just run these commands in your terminal. And after that, we can start the steps in mentioned section named Push an Existing Folder. As you can see here, I should navigate to the existing folder for my project. I've done it before. And as you can see here in your terminal, we are in our new project named Git example. And then I should run the command for initializing the project that you remember that we did it before. And as you can see here, we have .git folder in our project. So as the first command, I will run git remote command to create a connection that I've mentioned. As you can see here in this command, we can choose a name for this connection. For example, I choose origin, and also there is related URL to connect to this remote repository. After running this command, you will see the whole process will be finished and that's it. You have a connection now and can sync your future local changes with remote data. Now, if you want to be sure about your new remote, you can run another command named git remote get-url and the name of your remote. For example, in this case, it's origin. And as you can see here, you will get the URL of your existing remote. After creating this new remote, I will add some sample codes to our local repository and then I will sync them with the remote repository. So for this purpose, I will create new file in my project named, for example, new changes and add the piece of code to it. Now it's time to sync the data. For this purpose, we should run another command named git add. I should say a few things here. The first one is the order of the commands that are mentioned in the remote repository in GitLab. It will help you to do the right steps. As you can see here, there is the same command for git add dot. But what does it mean? If you want to add all of your changes together, you can use dot. And for some situations that you want to add some of your changes, you can use git add plus your file name. Before adding your changes, it's good to have an overview of your new changes. For this purpose, you can run a command named git status. You will see here recent changes. Based on this, you can decide to add which of these files to your remote repository. I want to add all of my new changes to my remote repository in GitLab, so I will run git add dot. Now, if I run git status again, I will see my file in a different color. The file name should be green and it means that it's tracked locally by Git but has not been committed and pushed yet. As an extra point, it's good to know that to stage a file is simply to prepare it finally for a commit. Git with its index allows you to commit only certain parts of the changes you've done since the last commit. Say you are working on two features. One is finished and one still needs some work done. You would like to make a commit and go home, but you wouldn't like to commit the parts of the second feature, which is not done yet. You stage the parts you know belong to the first feature and commit. Now your commit is your project with the first feature done, while the second is still in the state of work in progress in your working directory. Let's continue the steps. The next command is git commit. It means commit the file to your local copy of the project's Git repository. But before doing it, let's ask, what is a git commit? A commit is a version of your project. It represents a standalone version of your project and has a reference to all the files and folders that are a part of that version. And also there is another question. How do I make a commit in Git? In order to understand how we make a commit, we need to learn about 3 different spaces inside Git: the working directory, staging area, and commit history. The working directory is basically represented by the contents of our project folder. And as a hint, a directory is the same thing as a folder. It is sort of like a work branch where we can add, edit, and delete files in our project. The staging area and commit history are part of our repository. The staging area is sort of like a rough draft space. It is where we can add updated versions of files or remove files in order to choose what we want to include in our next commit. In .git folder, the staging area is represented by a file called index. And finally, the commit history is basically where our commits live after they've been made. In .git folder, the commit history is represented by a folder called objects. Let's coming back to the terminal and continue. For this purpose, I use git commit-m. In this command, we have a flag named -m, and it's for writing a message in our commit. For example, you can use a sample text in our remote repository and its initial commit, copy this one and paste it in our terminal for the first commit, and yes, press enter, and that's it. Now that we have committed our changes and written a small message for it, it's time to push these changes to the remote repository. I will use git push command to do it. It's git push origin and branch name. But let me explain something. In this command, origin refers to the remote copy of the repository that we have created before, and also replace branch name with the name of your branch. Because I did not talk about branch until now, I will put master and will explain branch concepts soon. Press enter, and that's it. Your new changes have been added to your remote repository, and if you refresh the page, you will find these new changes, and both of the repositories are synced now. Also, if you like to check more details in your remote repository, you can click on, for example, code menu and branches to find your branches. For example, in this case, you can click on code and branches and you will find master branch. But I will explain more about these tools soon. In this step, I should explain something about branches in Git. Git branches are effectively a pointer to a snapshot of your changes. When you want to add a new feature or fix a bug, you create a new branch to encapsulate your changes. This makes it harder for unstable code to get merged into the main code here, and it gives you the chance to clean up your features history before merging it into the main branch. But the question is how it works. Before we check different commands to work with branches, let's check the way of creating branches. As I mentioned before, It's important to understand that branches are just pointers to commits. When you create a branch, all Git needs to do is create a new pointer. It doesn't change the repository in any other way. If you start with a repository that looks like this, you create a branch using git branch command. After that, the repository history remains unchanged. All you get is a new pointer to the current commit. Note that this only creates the new branch. To start adding commits to it, you need to select it with git checkout command, and then use the standard git add and git commit commands. There are several commands to work with branches that I will mention them in a practical example. Now to check a real example, let's create a new branch first. For this purpose, I write git branch command and choose a name for this new branch. For example, calculation-process. In this example, we assume that we want to add a script to do calculation as a feature. So it's better to create a branch for it. And also as a hint, it's better to create branches with meaningful names to find the related changes in the future. After creating the branch, we should navigate to it. So I will use git checkout command to move to our new branch. So I will write git checkout and then I will use branch name. Press enter and that's it. Now if we check the terminal, we will find this branch. So it's time to add our new changes. For this purpose, I will go back to our project, create another file in the project, for example named calculation-service. And now I will add new scripts to it. And as soon as I feel this script works correctly, I am ready to push it to our remote repository. So after that, again, we need to use git add, git commit, and other commands. For this purpose, I will go back to the terminal. For the first step, I will write git status to check our new file, and then I will run git add command. After that, I can check git status again, and now it's okay. It's in green color, and now it's time to use git commit command. For example, we can add a message to it like implement calculation process or service or something like this. Now it's time to use git push command. But in this step, we can use our new branch name, that is calculation-process. Press enter and that's it. Now our new changes are on our remote repository. If I go to our remote repository and check branches menu, refresh the page, we will find our new branch named calculation process. Click on it and we will find our new file named calculation-service. Click on it and inside it we will find our new changes. And that's it. As an extra point, it's good to see a few other commands for branches. The first one will delete the specified branch. This is a safe operation in that Git prevents you from deleting the branch if it has unmerged changes. The second one will delete the specified branch even if it has unmerged changes. This is the command to use if you want to permanently throw away all of the commits associated with a particular line of development. And the third one will rename the current branch to a new name, and you can use it when you decide to change your branch's name. And the last one will list all remote branches. Now it's time to check GitLab environment more. As the first tool, we can check Manage Member menu in our remote repository more precisely. For this purpose, click on Manage menu and choose Members. We will be redirected to a new page that we will find all members that have access to this remote repository. For example, this user is mine and it has a role named Owner. Consider a scenario where one or more developers have joined your project and you want to add them to your remote repository. For this purpose, just add them to your remote repository with this tool, and in this way, they will be able to access and cooperate with you in this project. So click on Invite Members button and fulfill this form. At the first field, you should enter the desired developer's email, name or username, and then select his or her role. It should be chosen based on the access level of that developer. So let's select developer. And at the end, you can choose the expiry date for this new member. At the end, click on Invite button, and now you have new member on your remote repository. After he or she accepts this invitation on his or her email, you will have a new member in your remote repository and they can get your project. As another capability in your remote repository, you can remove this remote repository whenever you need it. For this purpose, click on Settings menu, then choose General and scroll a little bit down. You will find Advanced section. Click on Expand button, and in here you will find a section for deleting this remote repository. Please be very careful when using this feature. In case you have to use it in an emergency, click on Delete Project button and copy this name, paste it here, and at the end, click on Yes, Delete Project button, and you will remove the current remote repository, which is usually not recommended. As the next tool, you can check your commits on your remote repository. For this, click on Code menu and choose Commits. And in this page, you will find your commits that you have pushed. It's as an history of your commits, and if you click on one of them, you can check related changes. For example, if I click on Initial Commits, I will be redirected to a new page and find all changes for our new file. You will see our new file named New Changes, and you can check more details in this. Generally, Commits menu contains all of our commits. Okay, it's time to talk about one of the most important tools on a remote repository. Before talking about it, let's consider another scenario. Suppose you, as a developer, have made changes on the project and pushed them on the remote repository. Now you should ask another developer or your team lead to check and review your changes, and if these changes have been applied correctly, merge them with the main project. In this situation, we use a tool called Merge Request in Gitlab. In order to create a new merge request, let's click on Merge Request menu. And as you can see here, we have an environment that allows us to create new merge requests and also check previous merge requests in the future. For now, it's enough that I click on New Merge Request button. to have a form to create a new merge request. As you can see here, we have two different sections. The left section is for determining source branch and the right is for target branch. But what does it mean? For source branch, you should select the branch in your fork that contains your changes, and for target branch, you should select a branch from the upstream repository. In this case, we want to merge our new changes in calculation-process branch. With our main branch named master. Now, press Compare Branches and continue. In this new page, you will find different sections again, that I will explain them. As the first part, in title, you should enter your desired title for this merge request that tells about the generality of your changes. For example, implement calculation service. In the second one, as you can see, there is a text editor that allows you to write something more about your new changes, describe how can someone test it, and so on. For example, I will write something like explain something. In the following, there are two fields that you can select or leave them. For example, you can assign this merge request to yourself or another developer, and you can select a developer as reviewer of this merge request or leave them alone. And it's the same for milestone and labels. At the end, you see two merge options. The first one is for some situations that you want to remove your branch after merging it with the target branch. By checking this option, you will clean up your repository environment and prevent the accumulation of unused and merged branches. And the second one is squash commit. Squashing allows you to combine multiple commits in your branch's history into a single commit. This can help keeping your repository's history more readable and understandable. It's also optional, and you can check it or leave it. As the last step, press Create Merge Request button, and that's it. It's your new merge request, and if click on merge request menu again, you will find it here, and that's it. Now that we are in merge request menu, it's good to talk about different tabs in here. Our new merge request is in Open tab, and it means that we have it right now and we wait for a developer to review and merge it. And as I mentioned before, after merging this merge request, your new changes will be added to master branch and your merge request will be moved to merged tab. And as an extra point, closed tab is for merge requests that are closed for some reason and not merged with the master branch. Okay, as the last step, let's assume that all changes are approved and we can merge it. So click on your merge request. And in here, as you can see, there is merge button. So you can use it to merge your changes. And if you check again your changes, you will find all your changes in this merge request. And at the end, that's enough to click on merge. And that's it. Now your merge request is merged. And there isn't this one in Open tab, it's empty. And there is this one in Merge tab. And as I mentioned before, this merge request is merged now. It's time to get familiar with the concept of pull request in Git. For this purpose, I want to consider another scenario. Let's assume that we have another developer in our team, and now that your recent changes have been successfully merged and added to the master branch, he or she needs to receive these changes in his or her local repository, and in other words, he or she needs to update the master branch locally. In this situation, a concept called pull request comes into play, and the developer must use this to update master branch on his or her local repository. So we should go back to our local project and change the current branch to master branch. Now we are on a branch named calculation-process, and we have added a new file named calculation service to this branch. So I will use git checkout command to go to master branch. Now, as we are in desired branch, that's enough to enter git pull command, and easily we can get all new changes on our remote master in our local master. So enter git pull, press enter, and now we have been updated and all changes on remote master are on local master. In this simple way, we can take any new changes from any branch and have it on equivalent branch on our own local repository. As the next part, let's talk about another command in Git named git clone. What is it and how can I use it? In order to answer to these questions, I want to consider another scenario. Let's assume that a new developer has joined our project, and at the beginning of the collaboration, he or she needs to have our project on his or her system so that he or she can help us to develop it. For this purpose and to get our project completely from Gitlab, this new developer must use git clone command. To check the required steps, it's better to go back to our remote repository in Gitlab. As you can see here, there is a button named code, and if I click on it, I will find two different ways to use git clone. Now I will use the second way named clone with HTTPS, and I will put a link in the description of this video to know about how to set up GitLab SSH key. To use the second way, I should copy the URL by using this button, and then I should go to our local environment. I've created a new folder named new member, and in this folder, I will open a new terminal and type git clone and enter the URL at the end. Press enter, and after completing the clone process, you will all files of the project here, and it's the way git clone works. As you can see here, I have all files here named new changes or calculation service or something else, and that's it. As the last point, I like to talk about one of the most important topics in the world of Git. It is Git workflow. So I should say Git is the most commonly used version control system today. A Git workflow is a recipe or recommendation for how to use Git to accomplish work in a consistent and productive manner. Git workflows encourage developers and DevOps teams to leverage Git effectively and consistently. Git offers a lot of flexibility in how users manage changes. Given Git's focus on flexibility, there is no standardized process on how to interact with Git. When working with a team on a Git-managed project, it's important to make sure the team is all in agreement on how the flow of changes will be applied. To ensure the team is on the same page, an agreed upon Git workflow should be developed or selected. There are several publicized Git workflows that may be good fit for your team. Here, I will discuss the generality of Git workflow option. The array of possible workflows can make it hard to know where to begin when implementing Git in the workplace. Here, I will provide a starting point by surveying the Git workflow for software teams. Remember that workflow is designed to be guidelines rather than concrete rules. I want to show you what's possible so you can mix and match aspects from different workflows to suit your individual needs. The first question is, why should your team determine a Git workflow? Identifying a single Git workflow is a necessary step in ensuring rapid delivery. Software development teams encompass contributors from various backgrounds and experiences, and they are likely to feel comfortable with a workflow they've used previously. Without a single workflow, a team's development workflow could be chaotic and slow down cycle time. A well-defined Git workflow empowers teams and underpins effective collaboration, streamlines the software development process, and facilitates continuous delivery. By determining a singular Git workflow, teams can pave the way for smoother conflict resolution and a more coherent codebase. Git workflows empower teams to clarify roles and responsibilities, set boundaries, and identify areas of improvement. The second question is, what is a successful Git workflow? When evaluating a workflow for your team, it's most important that you consider your team's culture. You want the workflow to enhance the effectiveness of your team and not be a burden that limits productivity. Some things to consider when evaluating a Git workflow are: does this workflow scale with team size? Is it easy to undo mistakes and errors with this workflow? And does this workflow impose any new unnecessary cognitive overhead to the team? After reviewing these generalities about Git workflow, let's go for understanding the basics of Git workflow. Working with Git can be intimidating sometimes because it's easy to make mistakes that would mess up your repository. I believe that it's mainly because we do not really know what's happening to our files under the hood, even with basic Git commands. Hence, when working with version controlling, it's crucial to understand the different places where code can live. But why? It's because of effective collaboration with other developers, understand why certain errors occur and why Git sometimes doesn't behave as you expect to, better grasp branching and merging strategies or concepts, and better conflict resolution. A common misconception is that code can live only in two locations, either in our local machine or on a remote server like GitHub, Gitlab, Bitbucket, and so on. But in reality, code can live in 4 locations: working directory, also called the local workspace; staging area, also called the index; local repository; and remote repository, example, GitHub, Gitlab, and so on. Now, let's have a look at some basic Git commands we use daily and understand how code travels between these 4 locations or workflow. The first one is clone. We usually perform this step when we need to copy the contents of an existing repository onto our local machine. If we are creating our own repository, this step is irrelevant. The second one is push. Pushing your local changes to the remote repository is broken down into 3 steps. The first one is add. The add command adds a file or files to the staging area, which basically means that it's marked to be committed. But why do we need a staging area? It gives you flexibility and control over the changes you want to include in your next commit. In an IDE like VS Code, you can see your staged files and the changes in code that you have made in each file clearly. Commits in Git should be done thoughtfully and with caution. Hence, it is a good practice to always review your stage changes before committing. The second one is commit. After staging the changes, the commit command adds the staged changes to your local repository. And the last one is push. As the name suggests, it pushes the code to the remote repository. At this point, all the changes you have made to the code base will be visible and accessible to anyone who has access to the remote repository. Generally, when you are working with other developers on a project, you will regularly need to take in the changes done by others to your local repository and to your working directory. The pull command directly updates your local repository and your working directory with the latest changes in the remote repository in one go. It is a combination of fetch and merge, which we will dive into next. Fetch and merge is an alternative to the pull. The fetch command updates only your local repository with the latest changes. The merge command updates your working directory as a next step. Let's see how this can be useful instead of pull. On some occasions, you'll need to compare the incoming changes from the remote repository before updating your working directory. Fetch allows this. Once fetched and the local repository is updated, we can use the command git diff head to compare incoming changes. In other words, it shows the difference between your updated local repository and your working directory. As an example of Git workflow, let's have a look on centralized workflow. The centralized workflow is a great Git workflow for teams. The centralized workflow uses a central repository to serve as the single point of entry for all changes to the project. The default development branch is called main, and all changes are committed into this branch. This workflow doesn't require any other branches besides main. Transitioning to a distributed version control system may seem like a daunting task, but you don't have to change your existing workflow to take advantage of Git. However, using Git to power your development workflow presents a few advantages. First, it gives every developer their own local copy of the entire project. This isolated environment lets each developer work independently of all other changes to a project. They can add commits to their local repository and completely forget about upstream developments until it's convenient for them. Second, it gives you access to Git's robust branching and merging model. Git branches are designed to be a fail-safe mechanism for integrating code and sharing changes between repositories. The centralized workflow is similar to other workflows in its utilization of a remote server-side hosted repository that developers push and pull from. Compared to other workflows, the centralized workflow has no defined pull request or forking patterns. But the question is how it works. Developers start by cloning the central repository. In their own local copies of the project, they edit files and commit changes. However, these new commits are stored locally. They are completely isolated from the central repository. This lets developers differ synchronizing upstream until they are at a convenient breakpoint. To publish changes to the official project, developers push their local main branch to the central repository. This adds all of the local commits that aren't already in the central main branch. The first step is initialize the central repository. First, someone needs to create the central repository on a server. If it's a new project, you can initialize an empty repository. Otherwise, you'll need to import an existing Git repository. Central repositories should always be bare repositories, and it means that they shouldn't have a work directory, which can be created as this. Be sure to use a valid SSH username for user, the domain or IP address of your server for host, and the location where you'd like to store your repository. Note that the .git extension is conventionally appended to the repository name to indicate that it's a bare repository. The second step is hosted central repositories. Central repositories are often created through third-party Git hosting services like Bitbucket Cloud. The process of initializing a bare repository discussed above is handled for you by the hosting service. The hosting service will then provide an address for the central repository to access from your local repository. The next step is clone the central repository. Next, each developer creates a local copy of the entire project. This is accomplished via the git clone command. When you clone a repository, Git automatically adds a shortcut called origin that points back to the parent repository under the assumption that you will want to interact with it further on down the road. The next step is make changes and commit. Once the repository is cloned locally, a developer can make changes using the standard Git commit process: edit, stage, and commit. The staging area lets you create highly focused commits even if you have made a lot of local changes. Remember that since these commands create local commits, you can repeat this process as many times as you want without worrying about what's going on in the central repository. This can be very useful for large features that need to be broken down into simpler, more atomic chunks. The last step here is pushing new commits to central repository. Once the local repository has new changes committed, these changes will need to be pushed to share with other developers on the project. This command will push the new committed changes to the central repository. When pushing changes to the central repository, it's possible that updates from another developer have been previously pushed that contain code which conflict with the intended push updates. Git will output a message indicating this conflict. In this situation, git pull will first need to be executed. This conflict scenario will be expanded on in the following section. As I mentioned, if we have conflicts, we should manage them. The central repository represents the official project, so its commit history should be treated as sacred and immutable. If a developer's local commits diverge from the central repository, Git will refuse to push their changes because this would override official commits. Before the developer can publish their feature, they need to fetch the updated central commits and rebase their changes on top of them. This is like saying, I want to add my changes to what everyone else has already done. The result is a perfectly linear history, just like in traditional SVN workflows. If local changes directly conflict with upstream commits, Git will pause the rebasing process and give you a chance to manually resolve the conflicts. The nice thing about Git is that it uses the same git status and git add commands for both generating commits and resolving merge conflicts. This makes it easy for new developers to manage their own merges. Plus, if they get themselves into trouble, Git makes it very easy to abort the entire rebase and try again, or go find help. Okay, our journey in Git is coming to an end. I hope this video was useful for you and you decide to transfer your projects to Git. Thanks for watching this video, and if you enjoyed it or learned anything, please don't forget to hit like button. If you want to watch more videos, hit the subscribe button, and if you have something to say, leave a comment. So until the next video, goodbye!